Hi students, in this video we will be solving question number 18 from the exercise 3.2 from the chapter Matrices, and this is a possible 5-marker question in part D main of Karnataka second PUC board exam. Let us check question number 18 now. If A is a matrix 0 minus tan alpha by 2 tan alpha by 2 0, this is a 2 cross 2 matrix, and I is the identity matrix of order 2. Identity matrix is of the order 2 cross 2. Show that I plus A is equal to I minus A into this matrix, which is cos alpha minus sin alpha, cos alpha. Okay, so they say identity matrix is of the order 2. Why is it so? Because the given matrix A is of order 2 cross 2. That is why we have to consider identity matrix of order 2 cross 2 only. Even if they don't specify anything about the identity matrix, we have to check the order of matrix A and we have to take the identity matrix of the same order. If matrix A were to be of order 3 cross 3, then we should go for a identity matrix of same order 3 cross 3. Here matrix A is of order 2 cross 2. We have to take the identity matrix of order 2 cross 2 only. Now what we have to do is, first we have to consider LHS, I plus A. Then we'll simplify that. Then we'll consider RHS, that is I minus A into this particular matrix. Then we'll simplify and we have to show that both are same. Is this clear? Yes. We shall proceed now. I have written the identity matrix of order 2 cross 2. Then we'll consider LHS, that is I plus A. We will write that I plus A identity matrix plus matrix A. Now we will simplify the corresponding terms. So it is 1 plus 0, that will be 1. Then 0 plus minus tan alpha by 2. This will be minus tan alpha by 2. Then 0 plus tan alpha by 2. So this will be tan of alpha by 2. Then 1 plus 0. This will be 1. So this is I plus A, which is our LHS. Now we have to consider RHS and substitute for I and matrix A. Then simplify. After all simplification, we have to get this matrix, that is 1 minus tan alpha by 2, tan alpha by 2, 1. This is what we have to get for the RHS also. Okay, just look at the angle. It is tan alpha by 2 in the final answer. And what they have given here is alpha. Okay, now we'll consider the RHS part. RHS is I minus A into this matrix. We'll substitute for I and A. This is identity and this is matrix A and this particular matrix. Now we'll simplify these two. That is I minus A will simplify, then multiply with this matrix. Consider corresponding elements. 1 minus 0 is 1. 0 minus of minus tan alpha by 2 is tan alpha by 2. Then 0 minus tan alpha by 2 is minus tan alpha by 2. Then 1 minus 0 is 1. So this is I minus A. Now we have to multiply this matrix with this matrix. Now for that, first we will consider first row, then first column. Then first row with second column. Isn't it? Yes. So first row with first column would be 1 into cos alpha plus tan alpha by 2 into sin alpha. Be careful about alpha and alpha by 2. So it is cos alpha plus sin alpha into tan alpha by 2. Now I am going to consider first row with second column. We are going to multiply the corresponding terms. 1 into minus sin alpha, which will be minus sin alpha, then plus tan alpha by 2 into cos alpha. So it is tan alpha by 2 into cos alpha. This is the second term. Now we are done with first row. Then we'll consider second row with first column. So this is minus tan alpha by 2 into cos alpha, which is this. Then 1 into sin alpha. So plus sin alpha. So minus cos alpha into tan alpha by 2 plus sin alpha. Now second row with second column. So this is minus tan alpha by 2 into minus sin alpha, which will be plus sin alpha into tan alpha by 2. Then this will be 1 into cos alpha. So plus cos alpha. Is this clear? By now you should be thorough with matrix multiplication. Here it is the same matrix multiplication but with trigonometric terms. That's all. Okay. Now look at the terms. What all we have? We have sine and cos functions and also tan function. So there are three different functions. Now look at the angles. You have to be careful with the angles also because we have two different angles. One angle is alpha, the other angle is alpha by 2. Just be careful while writing the angles. Now we have to simplify and we have to get what matrix we got for I plus a. So for simplification, instead of keeping tan alpha by 2, we can write this tan alpha by 2 in terms of sine and cos function, right? So that we can proceed with simplification. So we know that tan theta is equal to sine theta by cos theta. So we will write for tan alpha by 2 as sine alpha by 2 by cos alpha by 2. See, we have this tan alpha by 2 in all the terms here, everywhere. So I am replacing tan alpha by 2 in all the four terms by sine alpha by 2 by cos alpha by 2. Look at this. Here I have replaced. Here again I have replaced. Here also I have replaced and here also I have replaced. Is this clear? So we have just replaced tan alpha by 2 by sine alpha by 2 by cos alpha by 2. Now look at the terms. We have to simplify this. To simplify that, we can take LCM and simplify, right? Yes. If when you try to take LCM, just check what do you get. Look at the very first term. The denominator term here is 1. In this case, the first term. Here it is cos alpha by 2. So our LCM will be cos alpha by 2. So we can take LCM as cos alpha by 2 here. Here again you check the denominator will be cos alpha by 2. So for all the four terms, the LCM will be cos of alpha by 2 only for all the four terms. So we'll take LCM now. What happens when we take LCM? This cos alpha by 2 into this term, correct? Here again cos alpha by 2 into this term. Then cos alpha by 2 into this term in the numerator. I'm talking about the numerator. Denominator part you already know it is cos alpha by 2. So here cos alpha into cos of alpha by 2 in the numerator. Is it clear? Yes. So we'll write the LCM. So I have retained that term to this slide also. Now I'm taking LCM and writing it. So when we multiply, it is cos alpha into cos alpha by 2 plus sin alpha into sin alpha by 2. Look at the denominator. That is what I have written. In the denominator, it is cos alpha by 2. For all the four terms, the denominator or the LCM is cos alpha by 2. So I have written that here. Now for this term, it would be minus sin alpha into cos alpha by 2. Right? Yes. This term will remain as it is plus cos alpha into sin alpha by 2. That is the numerator part. Clear? Yes. Now again for this term, minus sin alpha into sin alpha by 2 as it is plus sin alpha into cos alpha by 2 will be here, whole divided by cos alpha by 2. Now for this, sin alpha into sin alpha by 2 plus cos alpha into cos alpha by 2 whole divided by cos of alpha by 2. Is this clear, students? You already know how to find LCM and simplify. It is the same rule of finding the LCM and simplifying for trigonometric functions also. Just because they are trigonometric functions, rules of LCM and simplifying does not change. Keep that in mind. It is the same thing. You just have to be careful when it is alpha, when it is alpha by 2. That's all. There are only two angles, alpha and alpha by 2. You just have to be cautious about that only here. Otherwise, the simplification remains the same. If at all it is confusing to you, just take cos alpha as A, cos alpha by 2 as B, then sin alpha as C, sin alpha by 2 as D. Then simplify. It would be easy if at all it is confusing. But it shouldn't be confusing at this stage of your second PU. Isn't it? Yes. So after simplifying, just denominators are cos alpha by 2 only for all the terms. Don't worry about denominator now. Now look at the numerator part. In all of this we have to check, but let us check the very first one. Look at what do you have? Cos alpha by 2. The same angles here plus sin alpha by 2. Do you identify the form? It is cos A cos B plus sin A sin B, or cos x into cos y plus sin x into sin y. Isn't it? Yes, it is nothing but cos of x minus y, or cos of A minus B. So what is the formula? Look at this. Cos x cos y plus sin x sin y is cos of x minus y. That is what it is, right? X is alpha and y is alpha by 2. Okay. Now, if you look at this, here it is sin and cos both the terms. Correct? Sin and cos both the terms. But look at this again. Cos term, two cos terms together, two sin terms together. Definitely it should be cos of x minus y. Isn't it? Look at this. It is the same thing. The moment you see, you should be able to identify by now. So this is cos x cos y plus sin x into sin y. So it is again cos of x minus y. These two has to be sin of x minus y or sin of x plus y. Isn't it? But there is a negative sign. It can't be sin of x plus y. It has to be sin of x minus y only. There is little modifications that you have to do to get it to this form. Correct? Now look at it. You know sin x cos y minus cos x into sin y. You know sine function is the odd one. You cannot interchange these two. So this has to be x minus y. That means sin x into cos y has to be the first term. Now look at this. If x is alpha, then it is sin x cos y plus cos x sin y. Correct? So if I take out negative sign common, then I will get it in this form. Isn't it? If I take out negative sign, then it would be sin alpha cos alpha by 2 minus cos alpha sin alpha by 2. Correct? Yes. So this will be sin of x minus y with a negative sign. Okay. Again, this term is similar. Sin x cos y minus cos x sin y. You just have to interchange these two terms to get the standard form. Isn't it? Yes. We will do that now. So if at all it is confusing to you, I'll be showing the compound angles formula. You can compare, understand. Just pause the video, compare, understand the forms, then apply. Clear? Yes. Now just to make you understand, these two I have not substituted. Okay. I have substituted only these two because they both are same. What are the angles? Alpha and alpha by 2, right? So it is cos of alpha minus alpha by 2 whole divided by cos of alpha by 2 as it is. Now for this, cos of alpha minus alpha by 2 whole divided by cos of alpha by 2. For these two terms, it's the same formula I have applied. Now for these two, we'll make the required changes, then I will apply the formula. For this, I am taking negative sign common. For this, I am interchanging the terms. Very simple. So you can check here. I have taken out the negative sign. It is minus of sin alpha into cos alpha by 2 minus cos alpha into sin alpha by 2. Here denominator is cos alpha by 2 only. Here I have interchanged the term. This term and this you can compare. It is sin of x minus y only. Correct? Yes. Now we will substitute that formula also. These two will remain as it is. That is cos of alpha minus alpha by 2. Denominator is cos of alpha by 2. So it is the same term here also. These two are same. Now negative sign as it is. Then this is sin of alpha minus alpha by 2. Here it is just sin of alpha minus alpha by 2. And definitely denominator remains the same. That is cos of alpha by 2 for both the terms. Both cos terms have positive sign. But here sin terms have opposite sign. Here it is negative and here it is positive. That's all. It's the same formula for these two terms and for these two terms. Okay. Now look at the angles. Here we could not simplify any further. We had to retain as x minus y only because x and y are two different angles of which we don't know the value. But here they are like it is alpha and alpha by 2. It's not like alpha and beta by 2. It is alpha and alpha by 2. So I can very well simplify this. I'll take LCM of this. So it gives us 2 alpha minus alpha by 2. So it is alpha by 2. So instead of retaining this angle, I will substitute as alpha by 2 in all the 4 terms because the angle is same in all the 4 terms. So I will substitute that. That will be cos of alpha by 2 divided by cos of alpha by 2. That gets cancelled and becomes 1, right? Yes. So minus sine of alpha by 2 by cos of alpha by 2. Now look at the angles. It's alpha by 2 in both the cases. Numerator and denominator has the angle as alpha by 2 only. So sin theta by cos theta will be tan theta. Because in LHS our term was in tan function, not in sine and cos. So we can write this as tan theta, right? So I will write this as minus tan alpha by 2. Can we write it? Yes, we can very well write it. Now this will be again sin alpha by 2 by cos alpha by 2. Again this is tan alpha by 2. Yes. Now this will be cos alpha by 2 by cos alpha by 2. Gets cancelled and becomes 1. So look at this. 1 minus tan alpha by 2. Tan alpha by 2, 1. So this is nothing but I plus A. Correct? Yes, we have proved it. This is not a very difficult sum, students. You just have to know your compound angles formula. That is very basic formula you need to know. You just have to make a small change in these two cases so that you can apply this formula. Otherwise, it is very simple. You just have to understand that there are only two angles, alpha and alpha by 2. And where to write alpha and where to write alpha by 2, you should know. That's all. Easily, you can solve this and you can easily score 5 full marks. If you still have any doubt, please do mention it in the comment section.